Hello everyone, welcome back. In this lesson, we're going to explore three really important Python data structures, which are lists, tuples, and dictionaries. I'll start with the basics of each one, then we'll build up to slightly harder examples and finish with a kind of mini challenge. By the end, you'll see how these structures make your code more organized and useful. Let's begin with lists. A list in Python is an ordered collection that we can change after creating it. Here I will create two lists, one with numbers named as nums. Let's just put 10, 20, 30, and 40 in it. This is a list of integers. Then we can create another one with different types like text, number, a boolean. Let's just name it mix because it's a mix. Then we can add, for example, UAA, our school. We can add the pine number 3.14. We can add true, that's a boolean, and we can add the string cs. So this is a mixed type. Then we can say print nums and print mix. Uh, yeah, so when I print them, Python shows me the square brackets. As you can see, we can access items by index. Um, for example, if we do nums 0, it will give the first element of nums. If we say nums minus 1, it will give the last. So for example, if we say print nums 0 and then nums minus 1, then we should get, as you can see, the first and the last element on the list. Slices also work uh, like this with this structure: print nums 1, 2, 3. This means elements uh, 1 and 2. So this is called 0, this is called 1, this is called 2, this is called 3. Elements so 1, 2 through 3 means the first and the second element, and the third is not counted into the list. Uh, since lists are mutable, we can actually change the lists. For example, if we right here say nums 1 is instead of 20, we can say 200, and then we can, if we print nums again, as you can see, the 20 value changed into 200 instead. So this was for the list basics. We can get into some list methods. Let's just, for example, define a groceries. Uh, Groceries is, for example, let's just say milk and eggs, for example. And then there is a method called append. It basically adds elements. It inserts elements at the end, like commonly, and you can choose where to add if you use insert instead of append. So let's just say groceries dot uh, append. Let's just say bread, for example. Um, and we can say groceries dot insert. Let's just say the first to be T, for example, and then we can print groceries, and as you can see, the bread is added onto the end. The T is added as the first value, as this is the zero, like 0, 1, 2, 3. So yeah, this is how these methods work. We can also remove elements by saying, for example, groceries dot remove T. Um, and we can also pop. Yeah, as you can see, it's recommended. We can groceries dot pop the last item. So yeah, it pops out the last value and gives it back to the user. So you can say print groceries and popped last item. So it basically gives us the groceries list, like the updated new groceries list, and it pops bread out and gives out as a item. Um, so we can also count the index. Let's just create a letters list. Let's just say it is A, B, another A, C this time, and another A. We can say, for example, print count of A. Be careful to put, like, if you want to put double like these signs, you have to put the single one of them inside so it doesn't get confusing. And you can just say letters dot count A. So this should give, for example, 3, because like basically there's 3 A's. So also sorting is important as well. The method sort changes the list itself, while the sorted returns a new sorted copy. Of course, we can reverse the order with using reverse. I can just show you. For example, if we write a list of scores, which can be 50, 20, 90, and let's say 70. And then if we say scores dot sort, and just say sort print, let's just say scores, it will sort it out as 20, 50, 70, and 90, like in a small to big list. So yeah, you can also sort in place. So like you can say print sorted, instead of saying like just basically sorting it, you can choose how you sort it. So 3, 1, 2, and this sorts it like in the, again, from the smallest to the biggest. So if we uh, these lists can also hold other lists. For example, if we make a two-dimensional grid, like grid equals you don't have to do this, but yeah, 1 2 3, and then this is over, then 4 5 6. So these are different rows, and if we print grid, for example, since this is a grid, it will print exactly how it is. For example, if we say print grid 1 to 2, it will sort out 6, as this is 0, this is 1, and this is 0 1 2. So these are basically like coordinates. This shows which box, like the first number shows which box our wanted number is in, and the second number shows where in this specific box the number we want to choose is in. um, so uh, if we get onto tuples instead, uh, tuples look like lists, but they use parentheses instead of square brackets, and they're immutable, which means you can't change them after they're created. Uh, so if we create a tuple called, for example, let's say it's point, this is, for example, a coordinate point, let's just say it's 10 to 20, and then if we print it, point 0, and then point 1, as you can see, it prints out both of these points. And if we ever try to change it, it is not allowed, as contrary to a list. So yeah, we can still access items by index. This is often used for fixed data, like some coordinates. Another example we can give is we can, for example, choose a student record with names, grades, schools. For example, like student, um, just say my name, Mehmet, 12, and UAA. If we print student, it gives all of the information out. So it's, yeah, not interchangeable. Um, yeah, a I can assign x, y, point to split the values into two variables. So we can, for example, say x, y is point. I think we used point before, so we can say points, or point 1. Then, for example, you can say print x, y. So this is going next to this points. So the x, y variables are now 10 and 20, as because it was listed before as tuples. This is how it is used to get some data. Yeah. So finally, the dictionary. This is one of Python's most powerful structures. Um, a dictionary stores data set as key value pairs, which means instead of using positions, we access values with labels. For example, here is a dictionary about a person. Let's just say person equals, just say, for example, name. Yeah, it gives the values, as you can see here. Name Mehmet, age let's say 18, school UAA. So if we say, for example, print person as a whole, it prints as a whole. If we say person um, name, for example, um, it prints just Mehmet. So this is how uh, these dictionaries are used. We can also update existing values. Let's just say um, person uh, age equals 20. Uh, and then we can also add a new key. Let's just say, for example, person city. Let's just say Istanbul. And then when we print this new person, we can see we get the age as updated, and the city it is added into the dictionary as Istanbul. So yeah, so dictionaries, they also give us views of all their keys, values, both together as items, which are pairs. Removing is also easy, as we can just use the um, pop from earlier. For example, we can say remove city is person dot pop city. And if we for example print remove city, this will print out Istanbul. And if we try print person now, oops, let's just see, yeah, um can do yeah, to remove this we can just do last pair person dot pop item, and we can do print last pair. uh okay, that error was so weird. I think I just had to like these sometimes reset, so I had to like make it work again. So yeah, as you can see, it prints out the pop city. It it shows the last pair, which is age equals 20 from here, because the last and the it also only shows Mehmet, name equals Mehmet now, because these are all gone. This information is all gone. um so yeah, uh we can merge two dictionaries with update function as well. uh for example, if we say extra equals uh so say yeah, age equals 21, uh and then say country equals Turkey. If we say person dot update extra, it will as you can see add new information. Since also age was also included, it just changed the value. But no, it was popped, so it's, yeah, it's wrong. So yeah, overall dictionaries are great for storing information. like information like settings, user info, or usually small databases. So dictionaries often work with lists. For example, imagine a list of students where each student is represented as a dictionary. With this, we can loop through to count how many passed. Uh, we can also sort them by name using the sort method with a key. This makes it easy to manage a collection of records. So, for example, if we had to say students uh, equals to uh, so for example name, let's just say Mehmet, uh, grade 12, and then let's just say passed. For example, for any exam, let's just say true, for the sake of it. And then we can say the same for, yeah, this random person, and you can see the same thing. And then, for example, if we say past count is uh, is 0, and if we make a little loop here for SN students, if s past, so if past is true, past count plus equals 1. So yeah, if these people have passed as true, the past count equals to 1. So we can say for this uh, brand past um, past, yeah, count of len students. Yeah, so two, as you can see, only one out of two students seem to be have passed. We can understand by taking the length of this dictionary students, which only includes two people, Mehmet and Ali. One of them passed, one of them didn't. So when we look at the pass count, it will only appear as 1. So yeah, this overall makes it, I think, easier to manage some collections or some records. It could be student information, bank information, anything that's related to some kind of structure. Thank you for listening to me. This was data structures. We got our lists, their methods, tuples, dictionaries, and created a final function uh, that properly functions. Have a nice day, people. Bye.